Okay, so here is the division rule using the reciprocal, which is the process I'm going to be quizzing my students on. It is an attempt to get my students to understand a little bit more than just the procedure for using the reciprocal. I want to actually embed some of the concept into that. So what you basically have is a problem like let's say example 1. If you have 2 divided by 1/3, if you're just taught the procedure, you're taught this, 2 times 3 over 1, and then that tells you 2 over 1 times 3 over 1, and that gives you 6 over 1, because 2 times 3 is 6, 1 times 1 is 1, and 6 over 1 is just 6. That would be an example of how to just do the procedure, and I don't appreciate that as much as I appreciate understanding the concept. So it's in this step right here where we take the reciprocal that a procedural student will just take it on faith. You know, somebody tells them to just flip it, okay, they just do that. But I want to actually attack this from a deeper angle to show you how logically it actually it works out to be the reciprocal. Because if I don't explain it to you that way, then you just basically think, you know, I don't know why you flip it, but you do. So, in fact, there was a teacher that I knew years ago who didn't want to go into the concept of this, and so he came up with a little rhyme. Don't ask why, just flip and multiply. That was his little gimmick. But the concept is lost right here. If you just do the procedure and you don't talk about the concept, that's where you lose it. So, I want to attack this problem, same problem, from an angle that at least attempts to embed more of the concept into your minds. So let's look at 2 divided by 1/3. Or actually, I guess the starting point would be, let's use a whole number first. If we had like 2 divided by 4, I want you to think of that as 2 divided by 4. In fact, in more advanced math, at least in my experience, we don't see this sign that much. It's more of an elementary sign. And if you ever do see it, you want to translate it into these terms so you can move on. And of course, 2/4 would you know, reduce down to 1/2. And so, this little journey starts with, I want my students to think of 2 divided by 4, think of it and actually rewrite it this way. This number underneath that number. So, that's the first step, is I need you to understand when you're dividing 2 divided by 4, it's this one, the numerator, down underneath the denominator. So let's now take a look at a problem where we actually have a fraction, 2 divided by 1/3. According to what I just said, I want this number underneath that number. So I'm going to write it that way, 2 over 1/3. And you'll notice I made this fraction bar really a lot longer than the other one, because I want you to think of this number divided by that number. Even though this is a fraction, and some people freak out about that, you shouldn't. It's just a number divided by another number. Now, the next step in this process is to actually convert the 2 into a fraction. And let's come down far enough so that we're not crowding this. 2 over 1, I think we can all agree 2 over 1 is that number. Any number divided by 1 is still itself. Over 1/3. And so we still have 2 divided by 1/3. Chew on that for a second. Now, the next step, we have a big compound fraction, and we're going to multiply it times another compound fraction, but it's going to be specially crafted to annihilate the denominator. And there's also something very peculiar about it. This compound fraction is going to, as we know, this is what we have. And we can't change this. If we illegally change this, we'll get the wrong answer. whatever we do to this fraction, and trust me, you can do anything you want to it as long as it's legal. And what I'm getting at is what we're going to multiply times here is 1. It's going to be like a giant, complicated looking 1. And if you remember our talk about the multiplicative identity, anything times 1 is still itself. So, for example, over here, 2 times 1, you still get 2. 3 times 1, you still get 3. That's the multiplicative identity. That's why it's legal for me. As long as this giant compound fraction is equal to 1, we can do it. So, theoretically, if I did multiply this times 2 over 2, that would be okay. Of course, the way it looks here, it wouldn't be very easy to deal with. So if we did do that, it would have to be like this. And that's still 2 over 2, which the whole thing is 1. But this wouldn't help us. If we work this out, 2 times 2 is 4, 1 times 1 is 1, in the big fraction bar, 1 times 2 is 2, 3 times 1, that wouldn't really help us. But if we craft this with the reciprocal of this, so 3 over 1, now we actually would be getting somewhere. So you can still see this fraction is 3 over 1, 3 over 1. Anything over itself is 1. So this whole thing, in other words, is, like I said before 2 or 3 times already, a giant 1. And we might as well label it multiplicative identity. So it's because it's a giant 1 that we can multiply it times this, and even though it changes the appearance of this, it's still the same identity. The identity doesn't change when you multiply something times 1. So, but this one's been specially crafted. 2 times 2 is 3, 6. I mean, 2 times 3 is 6, excuse me. 1 times 1 is 1. 1 times 3 is 3. 3 times 1 is 3. Aha! Right there. That's the whole reason we picked the reciprocal, was so that this would happen, because this is also 1. And as you know, anything divided by 1 is still the anything, which is kind of the multiplicative identity in the opposite direction because we're dividing. So that would give us 6 over 1 over 1. So I'm basically ignoring, as we know, anything over 1 we can just ignore that. And the same thing happens here, we can still ignore it. I guess maybe it would look better actually to bring this 6 over 1 straight out here so you know that's where it's coming from. So it's kind of like my equal sign needs to go up that way. And then, because down here this is just gone. We could write it over 1, but there's no point. Just like there's no point in keeping this when we know 6 over 1 is just 6. So that's how we get the idea in our head that the reciprocal, because the net effect, we have 2 divided by 1/3. If we flip that and make it 3 over 1, so 2 over 1 times 3 over 1, we would get 6. And I understand this is kind of a long journey, but and it may seem complicated. It's only complicated in the explanation. The concepts are really easy. We took a 2 divided by 1/3. I told you the rule is to put this underneath it. Now we turn 2 into 2 over 1. So from here to there, nothing has changed. The identity is still the same. We multiply by a special giant fraction that's really just a 1, because anything over itself is 1. That's why it's still legal. This can multiply times that, and we still get the truth. But it's been specially crafted to sort of cancel out the bottom. So we just multiply across, and this gets annihilated because it's just a big 1. And that leaves us with this, which once again, we can ignore the denominator because it's just 1. Anything over 1 is just the anything right back. And that's how I want to see it for the quiz coming up.